Okay, so we'll be generating the signals, type of signals, like this unit pulse, unit step, and unit ramp, and it means the same time. Maybe I can write on this PDF file while I'm explaining, just to make this one on. So unit impulse, this first one, is something doing like that's the x-axis, y-axis like this. So we can generate it anywhere in our x-axis. Okay, and the impulse itself, we'll see it here. It generates by default amplitude of 1. Okay. So the impulse would be, for example, at 1 second, for example. So we generate that one here, and the rest will be 0. Can be -1, for example. Can be any number. We can generate that unit impulse. Okay, it can be at 0 also. So at 0 time equals 0, which is our case here. After we'll be talking about this, we'll generate one pulse here, and the rest before 0 and after 0, all will be there's no pulse. That's what we call unit impulse. Unit step. Step. It's let's say by default we generated from 0, and it's like step, continuous step like this. Okay, which will be equal 1 all the time as soon as we are running our simulation. So this pulse can be delayed. Just check. Yeah, no need. Can be like can start from here, for example. Just trick this a little bit. Yeah, can start from 1, let's say, and what is before 1 is 0. Can be from -1 or -2 or any negative number. We generate that pulse all the way like this. Okay, so this is on the program, can be done also. So that's what you call unit step. That's a step, not pulse. Okay, it's a step. Unit ramp. All units here means 1. So once you generate that impulse, it will be amplitude for 1 for that impulse. Step will be 1 also because it's unit. You call it unit. Unit for ramp means something like the y equals ax. That's the like a line like that with the slope a, and that a equals 1 for unit here. Okay, so 1 for 1x will be given 1 in the y-axis and so on. So this is what you call ramp. So this we have exercises to be done to check those to reach that objective here for the first one. The second one, which is here, we use what you call piecewise signals. Means in x-axis we can before 0 or after 0, you can select segments in that x-axis, and we can generate different signals, or not only one. For example, here we have only one signal, which is the pulse. Here, which is the step, the ramp here. But here can be like, for example, let's say a rectangular waveform. Okay, and from 0, for example, to 3 seconds. After that, another one with the different amplitude, for example. After this, we can make like exponential and so on. So we call it piece. So pieces, the signal in pieces, and we call that operation here piecewise signals. So in different intervals, we can generate different functions or signals. Yeah, so this is one objective for this second objective here. The last one, no, there is one before, which is exponential signal, and you know what is exponential. Okay, the y equals e alpha t, for example. So it depends on alpha. If alpha is negative, so the exponential will be doing like this. If it's positive, it will be going up like that. Okay, so it depends on this number here, the polarity of that number. The last one, the exponentially variant sinusoid or sinusoidal. The sine wave. Sorry, I'm writing anywhere in this page. The sine wave, the normal sine wave is doing like this with the with the constant period and constant, let's say, amplitude plus and minus. Exponentially here, it will be doing, it will be decaying or increasing. Okay, depends on this alpha here. If alpha is negative, so that the sine wave will be starting like doing like this and following the exponential, path like this. Okay, so this is what you call exponentially varying sinusoid. Okay, if it's positive, this one, so the sine wave will start like this and will be increasing like that because the alpha is positive and the exponential is going up, not down. Okay, so those are the objectives or the signals to be generated during this session for lab number 3. If we start here with the first task, okay, and look, I modified this a little bit just to make it sure for you, which question you have to answer. So this is the exercise itself, and I believe you have an idea about what is that as syntaxes. Look, we need, for example, here to define the time. Okay, so the time can be in any equation. For example, in the literature, t can be between negative infinity and positive infinity, like this. But this is not supported by Matlab, of course. So what you do, you can specify a time. So for us, -2 means anything before t here, negative side, and 2 something after 0, which is a positive, time also. The step here can be modified. You can make it, and you can generate like more dots, more resolution for your signal, or you can make it, low resolution. The time will be the execution of this code will be done quickly. But for more clarity and more, more resolution for your signal, you can minimize this step here. So that's the time. So between -2 and 2, we need to generate that impulse, which is the first one I was talking about. So the impulse, as I told you, by default, the amplitude of that one is 1. So when to generate that one, when this condition is met here. Okay, so the pulse will be given when t equals 0. Okay, so here at t equals 0, that pulse will be, we can output that pulse and plot it here. Okay, and the amplitude for that will be 1, and the rest will be 0, like this. If we need to, delay it, like for example, we need that pulse to be generated at 1, not 0. So I have just to change this 0 by 1, and the pulse will be shifted here at 1 or -1 or any point you like. So you can just to modify that 0 with where you need that pulse to be generated. This is just to plot the variables created here. Each time you see like this, you just in Matlab you can type help stem, or in say in help, like that's Matlab. So here you can write stem, for example, and it will give you what is stem for, and with example it can be plot discrete sequence data and so on. So you can use help to understand more functions, okay? Because MATLAB, it's a notion of syntaxes, functions, and we cannot cover all of them in one session. So we take that time, we plot, the pulse regarding this time here, defined before, and you can ignore this. It will be like normal plot. Otherwise, you can make the thickness of the line in a 2, 1. You can make it more thick by changing this one or increasing this number here, and the thickness of the line will be thick. Yes, sir.
Impulse is a variable defined in MATLAB.
Yeah. Just write impulse. That's it. It will generate the pulse for you. But yeah, as soon as MATLAB will execute this, he will understand that he needs to generate the pulse with the 1 as amplitude, but where you define for him here where to plot that, to display that signal.
So it's a variable that takes it's a function or a variable.
It's a function. It's function. All these are functions. This function,
And
this is a function, but this to plot variables. I told you, not it's not variable. Plot this, take this t as variable, and the results here generated by this function will be variable also, like y, for example. Okay. You can name this one y equal impulse, and you come here, you write y equal t when t equals 0. And in STEAM, you can name it t and comma y. So those are variables now. T and impulse will be, or y will be variable, which is impulse itself. So impulse is function, asking MATLAB to generate a pulse with the dots all the way from 0 to 1. Okay, from 0 here in y-axis, all the way to 1. We have the dots to make that pulse or line. So for him, it's a set of the dots which are variables. Okay, here. Okay, is that clear?
clear.
Yeah. Now to plot this, we use this y lim also. I mean, we create limits, okay, in the y-axis from -5 to 1.2. You can. This is y-axis, by the way. Since the impulse itself it's 1, that's why we stopped it at 1.2. You can if you make it like 0.5, you cut that one at half, okay, or to half. If you need to see it all, you can increase this and make it more than 1. The negative 0.5 just to make the y-axis a little bit large in the negative side. Otherwise, you can keep it 0 here if you like, because the impulse generates a pulse from 0 toward 1, okay, as amplitude. So question 1, we're asking you here to run that script, okay, and let's try it only this one here, for example. First of all, let's copy it. Yeah, I have a Word file. Let's see. So let's, okay, I'm going to generate like a new script, Control V. The time will make, for example, from -1 to 1. -1 to, let's say, 3, for example, because I don't need you to understand that the negative and positive should be the same. No, can be -1 and 3, -100 and 1 here, doesn't matter. Okay. The impulse, I'll start at 0, and after that I will change it to 1. The thickness of that and make it 1. And let's start it. It will ask me to save it once I run. So we'll make it here for my case here. Call this one, let's say Q1. Save. Of course, yes. Okay, so that's my pulse. You see it? So at 0, sorry, I have a pulse from 0 to 1. Okay. And since I specified the time to be between -1 and the 3, that's why you see it not symmetrical, the position of this impulse. If I need this one to start at 1, for example, so make 1, make this one, let's say here, keep it 3, no problem. The thickness, I will make it a little bit thick. And here, let's start at 0. You see, so it's a thick, and between -1 and 3, like you can see, and the pulse is 1, and it starts at 1 because I asked them to generate that pulse at 1. Okay, now let's continue here. You have to do this. This is exactly what you have done. You have just to copy this and paste it in this question number 1 in that answer sheet. Not here, of course. Unit step. Now that was a pulse, and step here, you see there's another function, unit step also. It's called unit step, and I'm asking him to start from 0. and the same is the rest is same. Okay, if I take this, come back to here, there's another script function, sorry, file. Let's say, for example, I need that to start at 1. Okay, increase this bit a little bit, 5, and make this one 0. Okay, save it also. Is that clear for you, what I'm doing? That's question number 2, for example. And let's start it. Yeah, because it was open before. Okay, so I'm asking him to generate a pulse. Okay, it stops here at 5 because of the time. I'm asking just to stop at 5. You can make it 1 million. It will stop at 1 million, but it's going to take time to generate all those dots and that signal by the end. So if you need this one to start at 0, you have just to say that this unit step will be plotted once t meets greater than or equal 0, for example, and so on. Okay, so we have to run this script here and plot copy the plotted signal here as question number 2. Question number 3, we need just to make the same thing but using function. So how we can do that? We can just generate function. So in that function, you can every time you can change this the equation here, and you can use it for impulse, and you can use it for this pulse or step, okay, or ramp also by changing the y equation here. Look, I'm calling this function us. So once you save this, you have to save it with this name. You can change the name of the file, but you have to change the name of this function also. Should match the name of the file, the script file, and the name of the function should be same. Now this is a function. I'm asking just this is a pulse. So anything after 0 will be multiplied by 1. So a pulse equals 1, and anything below 0, it will be 0. And here there's one thing that you remember: the pulse, the unit step. Sorry, that unit step generates step with 1 amplitude of 1. If you need to make it bigger than 1, the amplitude, this is the case here. You can change this 1 by 2, by 3, by, you can make it even negative. That's anything here after 0 will be -1 all the way, or -10, okay, all the way like that. And before the time equals 0 equals the y will be equal 0. If you need a pulse with a negative, to be negative, and anything after time equals 0 to be 0, you can do it here. You change that 1 by 0, and the 0 by the amplitude you like for that pulse or step. Okay, so this is one thing to do. You copy this, you name it whatever you have. So whose name is Asad?
Doctor, by mistake because the screen is freezing.
Okay. So you copy this, you save it as US or any name you give it to that function, and you come to your script, and you can execute that one. So by executing those 3 lines, what you are doing, you're specifying the time, and after that, the next line, you are calling this function. The function will ask for a time which is given here. So we'll take that time, this segment of the time, and they will execute that y here according to your time, and plot t and y by the end. Okay, let's try it. Let's check here. So we'll take this. We'll see. Control B. Call it lab 3, for example, and save this. here with lab3 name, that's fine. So save. Okay, we come to another part here, and now I'm going to copy this. Control C, Control V, and of course the function file, and this file here should be saved in the same folder. Keep in mind that. And here I'm going to change, because if I keep it like this, it will be error. The name of the function is lab3. And I'm going to save this as say it was question 3, I think. Save. Now if I execute this, you see here, that's the function. Let's do it again, because that window was open before. So this is the function here. Okay, so between look at the time -2 to 2, and step is 0.01, and you know the pulse it's 1. If I need now to increase or decrease, let's say half of that, because this you know the impulse itself, the not the impulse but the step, the unit step, it's 1. If I need to half it, so let's make 0.5 here. Okay, just once I open this, this will be saved. You see the asterisk here, or that you know that the mark was here, disappears because it was saved. The file is saved. Now let's take this, close it, and execute one more time. You see the step now, the amplitude of step is 0.5, and so on. Okay. So you can play with this also. You can make it bigger in terms of amplitude. You can make it smaller. You can make it even negative. If it's -5, let's close this, run this one. So it comes here with -5, and you know you have from 0 to 2. We're plotting that pulse with the -0.5 as amplitude. I think it's clear and simple. So we did this. We have the answers of question 1, 2, and 3. By the way, this lab tasks here, the ones we are doing, the marks will be 3 marks. So we're giving you a gift right now. Here now, unit ramp. This is unit step, and you make it that step. Okay, once you multiply it by a time, you change it to ramp. It's same as before, except here we are using 2 functions instead of 1. Okay. Now, once you multiply, look at the dot here. Why I need to make a dot? Because we are not multiplying constants between each other, or constant with the constants together. No need for dot. Like 2 times 5, you make like only this multiplication symbol here. Okay, but if you have a function, okay, the function times another segment or array, you should multiply by dot and multiplication. You have to add this for sure. So same thing. You take this, execute it, and you know you have to paste the graph that you get here. Unit rectangle using a function here. Same thing. Okay, here we have just to by default this time here, that's the let's say the width of your rectangle. Okay, look here, for example, I mean this function should be saved by itself. You name it a rectangle or rect, like this, and after that you open another file and you call that function here. Now you specify this the period of that, or the width of that of this pulse. Okay, can be 4, can be whatever you like here. Okay, and you plot it. So I'll let you do this. They're giving you here unit rectangle. Okay, so that's the function, and why this is here, the place for that. Okay, let me verify this, and then by email I can tell you exactly what to do with this. Okay, so now those for the to generate the pulses, different type of signals in terms of impulse or step or ramp, and here the other part, which is the piecewise signals, like this, like I have told you. Okay, with a segment by segment, we can generate different signals. For this case, the time specified to be between -2 and 3 with this step. Here, anything before -1, like in this case here, just switch to this part so I can write on this file. Okay, so I'm asking in this line the time before -1. Okay, I need to have 0. That's why we multiply by 0 all that segment here. Okay. So we'll be having 0 here till we reach -1. So after -1, what we have to do? We have to take that h, the one generated before, and we add 1 to it. So we add 1 like this. You can add 0.5, so it will stop here at 0.5. You can add 2, so the pulse will be with amplitude 2. But when to stop and when to start, look here, it starts by default at -1. Okay, we have to specify this. And we're asking this pulse, okay, with that amplitude to stop at 0. I can make it a little bit large. For example, if I need it to stop at 1, so this will be 1, and the pulse will continue. For example, if this one is 2, so and this one is 2 here, so it will continue till 1, which is half of that. Okay, and after that, that it will be 0, equals 0. So that's the first function. The other one, I need to do this one, the last one. Okay, so same thing. Anything after each here will be 0 all the time for the same case till we reach 0, and after 0 or between 0 and 2, okay, we add -1. So we make it -1. You can make it -2. You need to increase the amplitude of that rectangle here. Okay, you can make it half of that, so 0.5, -0.5. Or you can make it like 3 or 4. 4 means after 2, we make it, it will increase it here, okay? Without, just move this. So you can make it 4 like that. So your signal by the end will be doing like this. Okay, step like that, 2 steps. Okay. Now, after 2, exactly after 2, we change it to 0. Or if I need to make it like half, means here I'll make it down here half of this, and I will continue with half. So we change that 0 with 0.5. So this is how you can make a different, or you can make a signal with the pieces different from each other in terms of amplitude, even in terms of function itself. You change that 1 by function. So the 1 means constant. Okay, look, a function, for example, y equals 1 or a. So that a can be declared before as 1, and you make here a or y. That's your function. So here you can change this a anytime. No need to touch that equation. You make it only one time. Every time you change this variable, the value, it will be assigned that variable, or this number will be assigned to this variable, which is declared here as, let's say, for example, this was a. So anytime Matlab will find a, will assign that given number here at the beginning. Okay, for example, you can declare it here. Now let's imagine, for example, and this is constant. If y is it's exponential, alpha t, for example, you can change this one with y, and you declare alpha before, to be -1, negative whatever, or positive whatever here as number, and y equals that. Or you can directly, instead of y here, you can change that number 1 or a with this function here. You write exponential alpha t, and so on, like that. The rest, it's plot function. This will plot t.
Doctor, why
Yes.
why do we have put h plus h equals h plus? Why can't we just put h equals and write the function?
Yeah, because he would understand that what was h before this -1. Okay, so and we declared here to be 0. You start. This is like we're making initial value for h at 0, and after that we take that 0. Like if you have done C++ before, you take I, you declare, you initialize it, and after that you make I equals I plus 1. Did you get the point? So here it's same. This instead of 0, we make this I will be h equal and 0, which is this. We're taking because it's not only one. It's because this one it's a digit, the I, but here it's like a set of digits. Okay, it's a segment. That's why we will tell that a segment, that segment here, multiplied by 0. Okay, make it clear, 0. Okay, make it null. Okay, to be more clear in terms of English. And after that, we can make this h equal the previous h, the initialized one, plus 1. But 1 here, we make it from where to where. If you keep it like this, it will be all the time 1 without stopping. That's the pulse. But if we need the pieces, we have to specify that one between which number or which time and which time. See it like this. If you understand that, this is same. Just not if I make h equals 0.
Doctor, what if I don't specify h for a segment? I don't say the value. What happens?
Sorry, again.
What if I don't specify the value for between -1 and 0, and I specify for every other value?
Yeah, it will be, look, if you have executed this before, it will take the previous number, the one stored in H. So every time as a programmer, once you start with any variable, you have to initialize that variable, just to be sure that your memory, the memory of your computer, didn't store anything in it. Because now, don't take it like a math or something only, but here, once you execute that in Matlab, he will take memories, okay, and store numbers. He will assign 0, for example, to H, or before it was like 6, for example, assigned to H, and they come and execute again the file. And for me, I'm waiting to have my function starting from 0, but it will start at 6 because I didn't initialize that, I didn't clear that variable H. We have to clear it first of all. So look, h equals 0. Is that okay with you? صح? Okay, now 0, but between which number and which number? I tell him anything before 1, clear it. Before a -1, sorry, clear it, make it 0. That's why we multiply that 0 by this segment here. So that segment, which is infinite, negative infinity till -1. Excluded that one. So anything here before that -1 will be cleared, will be 0. If you need to start, for example, at let's say 20, you make 20 here. So by default, once you plot, it will start at 20, and after that you will check till it will reach -1, and after that you will check what to do. Go up, go down, make exponential, signal, make whatever you're asking to have after here. Tell me if you're convinced, or so I can continue.
I'll continue.
Okay. Okay, so here the plot function, because of the time I'm running, just to explain the rest. Here we can you can avoid this if you like, those syntax, those lines here. But if you need to give a name to your x-axis and y-axis, you add this x label and y label, and you give you can name here whatever you like. This will be, for example, time s. If it's milliseconds, you make ms, so it will be written here ms. This is just for other users to understand this time, or this x, is it time, is it something else, or counts, or anything else. Also, this one just to make the size of this of that text be 12, like you're typing in Word, Microsoft Word. This is amplitude here for it will be written here for your y to identify the y-axis, and this is the thickness also, or the font size of your text. You can give a title. This is another function. Whatever you write here, it will be written as a title. Okay. I think here this is continuation, but this should be after this one. So this line here should be up here. Okay, so yeah, those are the limits for your x-axis. You can specify the time here to be, for example, -10 till 20, and you can come to in terms of plotting. So this for execution, those numbers, and after that I can tell him, no, I need just to plot between -2 and 3. I don't need all those numbers between -10 and 20. It's like you are zoomed in on that section here. Okay, same thing for y-axis. Here you can y-axis, you can make it -10 till negative or +20. Sorry, so it depends on the number you are using here. Okay? If the number here it's 10 and you keep this one 2, of course you're not displaying the whole signal. You are cutting the signal at 2, but you're asking to plot the signal here at 10 as amplitude, for example. Okay, the grid on, just to make a grid on your plot. Okay, you grid like that. There's no grid, but if I put grid on, I think this will be, yeah, there's error here. Maybe I didn't write it properly. Grid, not grid.
Do we need to put semicolon after plot?
No, it works. Look, after plot, no need. Okay, added the grid here. Okay, you can, if I make this one as a comment, and just close this. If I run, so you have it without grid here. Okay. So this is up to you. You can add grid, you can remove it. Let's go back here. So you run that function here and you get your result. You can copy it here as question number 6, sorry. The assignment, 6 marks. So you have in your that answer sheet, you have to include what you have done before here, because they're worth 3 marks, and the rest, this should be done by you. The other ones, just copy paste and run, and if there's an error, you can debug it to get the signal. And here we're giving you like a function. That's the delay. Okay, it's like the first one, except this is a delay -1, -2, the pulse itself. Or we can delay it, like we can start it at 2. I have done this in front of you before. So you can use this is as a time between -5 and 5. It is your time, and that's your function. And you can use this. This is a pulse. That pulse will start -2 at the first time, and second time you can now you can start at 2. Look, there is like once you do this plot, there's something called hold on and plot again. So you can plot t. If you name this one a t, you can plot t with y1, and plot t with y2. By doing this hold, I'm asking him to plot the first one, let's say -2, and he will hold in the same x-axis, the same axes here. He will add the other one at 2. So you can see both of them in the same plot. Otherwise, if you remove this section here, he will plot -2, and he will remove it and plot. He will show you only one plot. So if you need to show both plots in the same axis, you click hold between the plots. Hold on with space. You can Google it. Hold on Matlab. They will give you exactly how to use it. The other exercise here, we have to do as we have done. You remember I told you we can add more here. We have one piece from 0 before 0. It's 0. So h equals 0 times t t less than or equal 0. So everything is cleared before. After that, h plus 1 between this time and this time. After that, h it's like plus or negative plus -2 times this section here between 1 and 3 and so on. Another line h equals -1 times segment, which is bigger than or equal 3. So all the way will be all the time -1 and so on. So you have just to modify one of these this function here or this scripts, okay, to answer this question number 2. Generate the plot, generate and the plot square wave with the period 0.5 and amplitude of this. It's square. Instead of it's like a piecewise also, but before 0, before 0 it's 0, and after the period 0.5. So here you can make it 0.81 as amplitude, and after 0.5 you can clear it. So this will give you a rectangle or square with 0.5. So since it's a square, just only this word, they are specifying the time. Okay, so what will be the time? The time will be between 0 and 0.5 because it's square. Square means the height and the length also will be 0.5 here, which is the time, and 0.5 here. So the time is between 0 and 5. That's the period. Okay, so this is the time. Yeah, it should be like just a wave with that, because a square means you have to make this one 0.5. So anyways, that 0.5, the amplitude will be 0.81 as requested here. And it will be not square because it's like 0.8 and 0.5. It's like rectangular waveform. I think he made a mistake in here, but doesn't matter. You just put those numbers, you get your signal. Okay, you remember I told you here, you can change that one here by any function. This is the case now. So I'll give you time to understand this and try to work with this part in your in your code. Write Matlab code now. This is with what you call this exponentially, sinusoidal. Same thing here. You have just to make it exponential like that. Okay, but you can specify which time to plot. Okay, anything for this function, the first one, anything before -1, you can make it 0, and anything for this one here, and also before, segment t less than or equal 1, okay, that exponential should be 0, and t bigger than or equal 0 will be 0 also for the first exponential. For the second one, you make same thing, and before anything before 0 will be 0, and after 1 will be 0 also. So you're like eliminating this section and this section here. Same thing here, same thing here, and you keep only the one asked for you. It's like to become like a house like this once you plot it. Okay, so here it's the same. It's another function. Just keep in mind that now once you write it, you can write like multiplication normal like this, 4 times exponential -2 times t. Here, because we are multiplying function by function, so we make a dot multiplication. Okay, don't forget this, please. And cosine, and you can write the rest 6 times t here, minus 60, and you can specify the time and run your function.